Hello everyone, welcome to the channel. In this video, I am going to share a very fascinating and I believe quite a groundbreaking research by OpenAI. OpenAI normally is quite tight-lipped about their research, so I'm always very keen to know whenever they release these papers and they try to explain what is coming very soon from their side. And I believe this new research is going to become a new model and a new approach very soon, and that might change the way we look at text to image generation models at the moment. So let's get right into it. Just a heads up, it's not a hands-on demo or any installation. It is just a research, but I believe it is very important to know because that will become the foundation for various models in the future. So what's happening here? OpenAI has come up with this consistency model which tries to overcome one limitation, or I would say which tries to improve the diffusion models a lot. Diffusion models are AI models that generate realistic images, audio and video, but they are very slow. To address this, these researchers have developed this new approach called as sCM, or Simple Consistency Model. If you look at this diagram, and you will see that, let me actually rerun it like this. And let's go here. Bear with me. Now this gives you more idea. So you see on the right hand side we have diffusion model, and on the left hand side we have consistency model. Just look at the time difference. And if you look at the diffusion models generate samples gradually, taking dozens to hundreds of steps. This makes them slow and inefficient for real-time application. If you have been following my channel, you know that I have done heaps of videos where we use Comfy UI and mostly these stable diffusion models like ST 1.5, 2, 3, 3.5 recently, also Flux models, and all of them are diffusion model. They use the diffusion process and they take bit of a time. That is where real-time applications struggle, and OpenAI is coming up with this consistency model. So that is what is happening here. So this sCM is generating samples directly from noise in just 2 steps, making it 50 times faster, and it achieves similar quality to diffusion models without sacrificing performance, as you can see on your screen. And if you scroll down to this page, and I will drop the link to it in video's description, they have shared these more examples. Let me make it a bit smaller so that you should be able to see. Okay, that is better. Now if you look at these images, these are all of them which have been generated by this consistency model in just 2-step sampling. That's it. The quality is quite good, maybe slightly, I would say, less than the Flux model stuff. Very little difference, but not bad enough. So if your requirement is speed and you cannot afford any sort of latency, then this could be your friend, and there are a lot of applications here. So I'm scrolling down and showing you all of the images which it has generated, and you can check the vividness. Amazing stuff, really good stuff. So a consistency model is an AI model that ensures the generated sample is consistent with the desired output, as you can see here. It does this by directly converting noise into a noise-free sample rather than gradually defining it. So this is all there is to it. And the way this is working is that sCM is learning from a pre-trained diffusion model, and then it uses a simplified formulation to stabilize and scale its training. sCM generates samples in 2 steps, converting noise directly into a noise-free sample and then using it. Benefits, as I already showed you, 50 times faster sampling speed, comparable sample quality to diffusion models. Also, it is scalable to larger data set with just 1.5 billion parameters. And the real use case is when it comes to real-time generation of images, audio, and video. But everything is not perfect. There are few limitations. For example, one few of the limitation is that it relies on pre-trained diffusion model, so it's not something which you can create from scratch at the moment. Also, there is a small gap in quality compared to diffusion model. We just also noticed that. And then there is this FID metric limitation, but that may not affect the actual sampling quality. So I'm very hopeful about this project. I think this is going to be huge because OpenAI is going to continue to improve generative model for faster inference speed and better sample quality, and that is going to unlock new possibilities for real-time, high-quality AI applications. So if you want to summarize it in one sentence, what is the difference between this sCM and diffusion models? Diffusion models are like building a house brick by brick, whereas sCM is like using a 3D printer to create the house directly. Both methods produce a similar result, but sCM is much faster and more efficient, but diffusion models are more solid and more long lasting, and the quality will be higher, of course. Before I let you go, let me introduce you to the sponsors of the video, who are AgentQL. AgentQL is a query language that turns any web page into a data source. With its Python SDK and live debugging tool, you can scrape and interact with web content. AgentQL works on any page. It is resilient, it is reusable, and it structures the output according to the shape of your query. And I'm going to drop the link to their website in video's description. Plus, AgentQL is quite a robust alternative to fragile XPath and DOM CSS selectors, as it uses the power of AI to analyze the page structure to find the data you are looking for. That's it. I hope that you enjoyed this. If you like the content, please consider subscribing to the channel. If you're already subscribed, please do me a favor and share it among your network, as it helps a lot. Thank you for watching.